this computer. All right, so before the break, you learn about everything about runoff, but the cause of runoff is rainfall. So you got to understand how to interpret rainfall and how that is related to runoff. So rainfall is something you always hear from Weather Channel. It says 2-inch rainfall, or sometimes they say that we have flooding because we got 100-year storm event. What does that mean? 100-year storm event. Well, it means that this kind of storm event happens once in 100 years. Okay, so that's all it means. So that's exactly what we are going to learn now. So it's really not much difference. You heard it before. We just have example here. So the rainfall characteristic, when I say rainfall, how big, how small, couple of things you can measure it. First is the intensity or the size of the rainfall, which is usually volume, means how much cubic feet of rainfall happens. But as I said, if you know the watershed area, which is most of the time, people don't say that this much gallon of rainfall or this cubic million of gallon of rainfall. They say inch per hour. Is that means that how much if you drop all that rainfall on the surface of entire area, let's say 1 acre of area it rains, how big it will rise. So imagine an imaginary bucket and of that size and how big it will fill up. So that's why it says as rainfall depth or the intensity. So usually you multiply intensity to catchment area, you get the volume. So that's why you don't really need to write these big numbers. You always mention just the length. But it assumes that throughout the entire catchment you have the same amount of rainfall, which is not true, but that's the way to we have to average it. The second thing that you also note is durations. Duration, because 1 inch per hour rainfall for 5 minutes is very different from 1 inch per hour rainfall for 20 minutes. That means it's just the cumulative bits adding more and more. So you got to also express how long it has been raining. So that's why always is there the time. So you see that graph, that's what it means. If you say rainfall intensity, so they say inch per hour, this is like every 30 minutes, then this is, let's say, this first 30 minutes is zero, then it becomes zero, then suddenly it's become higher, then next one is a little bit smaller, then it goes all the way down. So that's how what it means, that every 30 minutes you record, um, you get this kind of, okay. So this is like the interval that you record time. So that varies a lot. So the duration is also important. Duration means entire time, how long it has been raining. This is duration. Depth, you already I explained you. It's basically intensity is depth, inch, how much inch of rainfall. So depth by duration, you get the intensity. So usually, these are the things average out certain way. So that's why it's depends how they measure it. One thing, like what people do report is a 100-year storm event or 50-year storm event. That's basically the frequency, how frequently this kind of rainfall happen in that area. So that frequency is depends on the probability of having that. So it's a probability case. So let's say there is a 20% of probability of having this rainfall every year. That means every 5 years you'll have definitely one of these rainfall. So that's a 5-year rainfall event. So this frequency or the return period T is 1 over probability. So let's say I have example. What is the recurrence interval for a storm event that has a 20% probability of being equal or exceeded, within any given year? So probability is 20%, and so return period is 1 over P. So 1 over 20%. So if you see 20% means 0.2. So it's 5 year. 2% probability. So if it's 2%, then recurrence period is always in year. So 1 over P is 1 over 0.02. So it's basically 50 years. So that means it's a 50 years period. So now question is, which one is high intensity rainfall? Well, usually if one rainfall happen once in 100 year, that means it must be very heavy rainfall. Okay, so the lighter or the smaller rainfall event, the more likely to occur any year. If it become bigger and bigger, that's obviously it's like a category 5 hurricane. How many times it will happen in that area? Maybe once in 10 years or 15 years. But now it has been happening more and more frequently. So that's why they say there is a result of climate change. Things are more frequent nowadays. So now that you learn, this another example just to show you how to do that graphically. Based on this graph, can anybody says answer this answer so that we can learn? What is the intensity of 100-year storm event at the locations? So I gave you 100 years. So what is the intensity of 100-year storm event? That means a rainfall that can only occur once in 100 years. Any volunteers?
Is it that high bar that goes up to 6.5 inches?
Yes. So this is 6.5 inch. So what does that means? 100-year event means it happens once in 100 years. So you just have to see in entire 100 year which rainfall happens just once. Anything above this line happens only once. Okay. So if you include those two, it happens twice. So that means if you say 50-year rainfall event, that will be more likely this one. If I say this, so this is 100-year rainfall event occurrence. This is 50-year because what it means that in 50 years you will have at least two rainfall, same or more than that. Okay. So if you say this one, if you include this one, anything same or above happens three times in entire 100 years or four times. Let's say there is another here. So if you look at 4 inch, there 4 inch of rainfall, it's more likely four times it happens in 100 years. That means the return period is 25 years. So you got to remember this. Just because it's 25 years return period doesn't mean that will happen within 25 years. It means that more likely they will occur in 25 years. Because you just have to take many instances to make that average. It's like the same thing. The earthquake happening in LA is, let's say, 100 years, or San Francisco. Doesn't mean that last earthquake happened more than 100 years ago. So it doesn't mean that it has to happen on the 100th year. There will be always some changes. Sometimes it will be more frequent in 100 years. Sometimes it will become a little far. So that's why you get the average. The second question, what is the return period for 4-inch 24 hours storm event? So this is a 4-inch. So that means you just have to see how many rainfall event happens for at least 4-inch or higher in that 100 years. So if you see 1, 2, 3, 4, so that means 4 rainfall events in 100 years. So that means the occurrence would be 25 years return period. Okay. How does the return period change with decreases in intensity of rainfall? So it is saying is, if I ask you what is the return period for 1-inch rainfall, as you can see, if I say that one, let's say that's the question I ask. As you decrease, let's say the minimum you say 1-inch rainfall. So let's count how many 1-inch rainfall in 100 years happens. 1, 2, 3, 4, 5, 6, 7, 8. So I'm just drawing the line here. Basically everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2. So 32 rainfall. So that means 100 divided by 32 is whatever that number is the occurrence for 1-inch rainfall return period. That's roughly less than 3 years. Okay, or around 3 years. Yeah, around 3 years. So that means every 3 years you will have a rainfall more than 1-inch rainfall. So that means as you decrease the rainfall, it's more likely the probabilities increases. So that means the return period The with decreases in rainfall intensity, the return period also becomes smaller and smaller, or the probability become higher. The last thing is a rainfall measurement in real world. How do you do that? There are many methods to do it. A very specific method is basically take your bucket outside, leave it outside for an area where it's not, the rainfall is not blocked by kind of a tree or a building. Let's say put on top of your building so that there is nothing blocking, and make sure that there is no drop that comes out of the outside and inside, so that it put it a little bit higher elevations. And also remember that there should not be any evaporation, or the evaporation has to be very small. That means as soon as the rainfall stop, you got to go and measure it. And so the depth you receive, you that's the rainfall inch. And so that means, you obviously cannot go outside and put a bucket and measure that. So what people do is they put a, it's called tipping bucket. So basically you have a bucket, but it has a container like here. It has a boat like this. Okay. So, and let's say this is the rainfall. Okay. So you have bucket here and it receive all the rainfall. It comes here. As soon as it fill the entire thing, it will flip. So it will go down like this. So it pour all the water. So then it will go back again. So then it will start filling again. So as soon as it again fill up the entire thing, it will flip. So every time you flip, it knows the volume, and every time it flip, that you have a magnet there, so it record how many times it flipped or it switched. So that means it measure the volume automatically. So let's say it says how many times, every 10 minutes, let's say every 30 minutes, it's just say that click, how many times it click, in that entire 24 hours. Then you will know, and how quickly it happens. Based on that, they can predict the inch per hour. So this is very effective method in many locations, but you just have to also know that there are issues with that. It is susceptible for wind, evaporation loss, because if the water will, if it is very small rainfall rate, evaporation become more prominent, because whatever rainfall happens, they're more likely, the significant fraction of that is evaporations. Sometimes that's why a smaller amount is not recorded, because it has to completely fill to be able to record once. It can have mechanical error, it can have leaves and debris can fall into that. And also it assume, because you can't put this one everywhere, so that means you assume that whatever rainfall you receive in that spot will be same as everywhere else in that water set. So that's why it's not very accurate. So to overcome that, the other method people use is radar method. So radar method, the way it works is it send the wave signals, and because of your raindrop, it reflect back. So by recording that distance, Doppler, so it's basically Doppler effect. That's what they call. That's what they use so in satellite. So the advantage of that one is it doesn't, it can, you know exactly, it's not uniform everywhere, so you exactly know which location. Thank you, thank you. Um, so the drops size, so that means you also, because it's a sound wave, so also the rainfall intensity, drop size, how intense at that locations, because you can scan it all over. So it has a lot of advantage. Okay, and so that's why most likely people use this method. So you can use this YouTube video to know how it works, because this is something used in satellite a lot. So the last thing is about rainfall data. Okay, so now you know how rainfall is measured. The couple of things you have to remember is, like, hydrograph means how much rainfall, how much runoff receive at on spot at different time. Hyetograph or heatograph, or whichever way you can pronounce, means how much rainfall receive at different time. So basically that time versus rainfall intensity is hyetograph. Basically that's what I explained already. The another thing is, for green infrastructure design, you got to know the rainfall characteristic that area, which means intensity, duration, how long it rain, and also the frequency. So that's why it's called IDFF period. intensity, duration, and frequency curve, IDF curve, and that's particularly set for every area because that's NOAA or weather service for different country. They monitor this thing for many years, so they already know the pattern. So that's how for each area there is a IDF curve. Means what rainfall intensity, how long. If you say if you are looking for, let's say I'm interested in to capture all rainfall that happens if 1 hour and for more than 2 inch per hour, and so then it will tell you what's the frequency, what likely it will occur. So for instance, Los Angeles, they use 85 percentile rainfall curve. That means they want every rainfall happen, 85% of the rainfall that happen in L area is going to be treated. Okay, so that means that 15% is very heavy rainfall. They don't want to capture it because it's just impossible, too expensive. So for L area, the IDF curve is 85 percentile rainfall. Okay, and 85 percentile rainfall is basically probability. Okay, so that, and that can vary from Westwood to, let's say, San Diego. Every location has their own intensity. It will tell you what's the inch per hour, and then you put that I value in your runoff coefficient. That's how you know how much runoff. So this is why it's very important you know how to get this IDF curve for any locations that you use for your project. And so you are going to learn that in next 10 minutes. So this is just to show that rainfall varies with time. For any given rainfall events, the rainfall patterns can also vary within that durations. It doesn't rain in the same intensity for entire time. So that's why different location has this curve. You can see NOAA has this data. It says which location receive more rainfall versus uh, less rainfall. And hydrograph, as I explained, this is basically x-axis time. You take sample at every different time what is rainfall, y-axis, it show you a patterns. And based on location, this hydrograph can also vary. Some location you receive a lot of rainfall in the beginning of the rainfall, and then it slow down. Some it start with very slow, and then it peak very heavily towards the end. So these kind of patterns are also depends on the climate in that area. So let's say in the California area, there is a different rainfall patterns than in, let's say, Philly area or Florida. And these are already determined. So you got to understand those numbers. So intensity durations, again, sometimes people always use 24-hour storm event to design this treatment system. What that means is that they say that in 24 hours, whatever the rainfall pattern should look like. So that's the, for instance, this is the example that's given. So what it means that, as you see, this is the how it works, the real data, and then they make a probability determinations. And then they can say that for that location, for instance, here, this is in New Jersey, it means that this particular rainfall, initially it was very low, then it peaks around 12 hour or 11 hours, and then it goes down certain rate. And so then you can feed these equations into your model, and then it say what the runoff will be, because you know the infiltration or that rate. And but a lot of times, as I said, how do you know what's the intensity? Because it has a lot of different intensity at different time. So sometimes you have to average it out, and that's what it happens here. So if you average it out, let's say for 3 hours, then your intensity is going to decrease. And the idea here is that the volume of water for under each curve will be the same. So if you're saying that I'm going to assume that in 3 hours all these rainfall will happen, then the intensity has to be small. But if you want to drop all that water in 1 hour, then obviously the intensity will be a lot higher. So that's what it means, that your choice whether you are designing for high intensity rainfall within certain time, very short time, or it's a low intensity rainfall distributed across longer. So that's something you have to decide for your design, and usually it's given to you. So how do you change it? If I say that I give you 10-hour rainfall, but you want to change that to 24 hours, basically this is the equation you want to use. So 24 hours, is this many, uh, this is multiplied 24 hours times 60 is this, okay, minute. And if you want to change that to, let's say, 1 hour rainfall event, or then you change that to into minutes. So you put this value times 47, that's how you can calculate it. um, this is useful if somebody give you 8 hour rainfall, then you want to convert that to 1 hour rainfall, you just change this number. um, Again, I just browse through it. Now I'll give you the handout. This is very simple information, so you can, when you read it, you'll understand more. Let's see how much you um, understand based on the rainfall intensity duration curve. What is the rainfall intensity of 0.2 inch rain occurs within 10 minutes? So inch per hour. So I'm asking, if your 2 inch rain happens in 10 minutes, what's the intensity in inch per hour? How many inch will be in 1 hour? So 0.2 inch in 10 minutes. All I'm asking is in 1 hour, but this would be. All right, so I'm going to end the poll. All right, so if 0.2 in is 10 minutes and then continue to rain for that long, obviously the inch would be 6 times more than that, because you have 6 10 minutes interval in that time. So if assuming this will continue, so that will be 0.2 times 6 is 1.2 inch. Okay, that if it is continue that way, okay, so that's the assumption. The last one, intensity duration curve, is basically, if you know a location, it will tell you this number. So all you have to do is just click on these things and it will take you a new web page. So it will tell you that information. So I um, I want you guys to try this on your own, but I also show you example, and the next class will discuss that. When we add this one, we'll integrate these functions over there. So I'll just show you in a video or in an actual website. So let me go to that link, intensity duration curve. That way you can, let me see, why did the intensity rainfall. Okay. So I'm going to stop sharing here and I'm going to share the actual video. Stop share. And that website is very slow now. If it is, it's already recorded. So otherwise I'll just share the recording from the last year, because I did that in the class. For some reason it said this site cannot be reached, this is taking so long for the server. So let's not do this one, but I'll share that video from last year so you can try later. Okay, so that's all for the class as far as the um, these lectures. But now what we are going to do is we're going to create breakout room. I'm going to create 5 questions on the homework. So I'm going to create 5 breakout room, and I'm going to say that you can choose whichever one. So room 1 means this is question number 1. Room 2 is question number 2 on your homework. Room 3 means question number 3 in your homework. And room 5 is question number 5. So I say open all the room. So you guys can choose. So what you do is you hover on the room. It says 0 or 1 or whatever things you see. It's if you hover the um, screen and that number or your mouse, then it will say join and just click there. So you guys join whichever team you want. Now, which question? I also don't know whether we can record any of them because if I leave the main room, so I'll probably stop recording because I don't know whether you can record entire 5 different rooms. So your responsibility once you learn how to solve each question, your goal, if somebody asks questions on that, to explain the other person um, on the campus where when you get a chance. Again, the homework is not due until next Monday, coming Monday, so you have some time. I just want you guys to try here to talk with each other. So upon the question, so I'm going to open the question now here so that you guys at least you see those question there. Okay, homework 2, share. So these are the different questions. But again, this is for me so that I can see, but you should open the question by yourself. Okay, so far I see that many of you are in the room 1 because that's the question you have, and I have also seen that 21 students didn't join any room. So if you are here, join one of those rooms. Room 1 means we are solving question 1. Room 2 means we are solving question 2. Room 3, you are solving question number 3. I see room 4 has only 1 student. Room 5 doesn't have any students. So please join, distribute yourself because we rather have some, we don't want one room has to 1 person. That doesn't make any sense. There are still 7 students who didn't join. So I would recommend you guys join room number 4 and 5 if you can. Or if nobody join room 5, then obviously you can go to any other rooms. If you are just 1 person there, maybe you not have any conversation. So just join that. So I'm going to stop recording now.